Hello. Uh, this is the APRP session 2 and 3:30, and so we're going to start. And the first speaker is Andrew Howard. He came from the NCI in Australia. And today he explained about this national computation infrastructure about that. Andrew, are you there?
Yes, Jong-hoon. Hello, everyone.
Yeah, so you look so good. And when you're ready, and start now.
Okay, thank you. As Jong-hoon said, I'm Andrew Howard. I'm Associate Director of Cloud Services and Innovation at the National Computational Infrastructure, which is one of the two high-performance computing centres in Australia. In Australia, we acknowledge and celebrate the First Nations people on whose traditional lands we meet, and we pay our respects to elders past, present and emerging. What I'll be discussing today is a short introduction to NCI, some concepts about some of the stuff we do, what we store, our systems, our archiving systems, our cloud systems. But most importantly, I'll be explaining the Data Mover Challenge 2023, which we'll be announcing the winners for at Supercomputing Asia next month. So I'll also be discussing that. So first of all, what is NCI? We're Australia's high-performance computing service. We operate as a collaboration from our national university, National Science Agency, the CSIRO, the Bureau of Meteorology, Geoscience Australia. They're our foundation collaborators. We also have partnerships with the research-intensive universities, supported by the Australian Research Council. NCI is directly funded by the Australian Government through the Department of Education. Unlike Korea, we don't have a centralised body which manages all research. We do have a national research network, but the research institutes tend to operate in a more independent manner. So we're located in Canberra, Australia. For those, we're on the east coast, approximately halfway between Sydney and Melbourne. Our sister computing centre, our sister high-performance computing centre, Pawsey, is on the west coast in Perth. We're located on the ANU campus. We've got a dedicated high-performance data centre, which is currently 10,225 square feet. We're just in the process of building another $12.9 million building adjacent to our centre, which will take us up to 15 megawatts of power capability. This is to handle the higher performing HPC systems, which are running up to 75 kilowatts per rack with direct liquid cooling. We've got around 60 specialist staff across high-performance computing, storage, cloud, user support, visualization, data catalogs, research engagement, and application optimization. We deal with the complete spectrum of science, fundamental, strategic, applied, and industry. We store a lot of cross-institutional collaborative scientific research collections, which a lot of your researchers in Australia and around the Asia Pacific use. The access model, which is Australian Community Climate, Australian and international data models from the CMIP5, CMIP6 and AR5 collections. A plethora of satellite imagery. We have over 30 years of Landsat data, INSAR, ALTOS, SkyMapper, the Sentinel program, the Australian Data Archives, and we hold nationally significant large-scale genomics and bioinformatics data sets. As Atif mentioned earlier, bringing all of those data sets together can be a quite time-consuming process to download them from multiple locations. So to make life easier for our researchers, we've pre-downloaded a lot of the research genomes and the reference genomes so they're available locally and they don't have to go through that pain. Our systems, we have a large computational system called Gardi, which we named after the local Ngunnawal Indigenous word, which is the Indigenous people in our area to search for. It was commissioned in 2019 and brought fully operational in January 2020. It uses a 200 gig HDR InfiniBand, around 3,024 compute nodes, 720 Sapphire Rapids compute nodes, 54 large memory compute nodes, 804 Broadwell Xeon nodes, which are being deprecated, around 160 Volta GPU nodes with additional GPUs being added. And we also have some large memory, some NVIDIA DGXs, special purpose nodes, and FPGA nodes for special workloads. Computation is only there to extract the value of the data, which was from one of our intensive data users. Our storage today runs over 4 tiers, with tier 0 being the ephemeral, high-performance, really high-performance Scratch data space. Our tier 1, high-performance computing systems. Tier 2, our active project data, which is the bulk of our long-term storage. And then tier 3, which is a tape system, which covers around 30 petabytes of offline storage. As you can see, our environment is completely integrated with our Niren Cloud, Australian Research Environments, which is a graphical desktop interface for high-performance computing, which is completely web-based, our data transfer nodes, our data services capability, our Guardi high-performance computing, connected to a wide range of file systems and storage capabilities. One of the challenges is tape storage. This comes from our storage manager. This is typical of a tape storage installation that we're in the process of deprecating at the moment. There's a lot of fiber channel zoning, host bus adapters, switches, fiber channel switches, fiber channel switch port licensing, hosts with different network capabilities, long-range dark fiber for inter-data center links, distributed troubleshooting, and then we add cloud in on top of that. It wasn't even thought about when most of these tape systems came online. File systems, you can pick one, you can pick a few, you can pick the file system which best suits your performance needs. Some of the constraints that we have, though, if the data hasn't been used or meets a certain criteria, what should we do with it? Should we keep it for perpetuity? Do we need to keep 1, 2, or 3 copies? Do we need to have isolated media or diverse media types? Does it need to have long-term persistence over potentially decades? Should we have geographically separated immutable offsite copies? Australia is quite prone to natural disasters, bushfires, floods, massive storms. So, we need to look at potential failure of a site. And is the archival data accessed so frequently that should be moved to a warmer tier? And what if the disk cache in front of the tape system fills up? So some of the traditional things, how do I back it up? Traditional backup architectures don't scale well into the many petabyte range. So we need to do things like examining the deltas, performing data compression, and trying to understand data growth, which is ongoing, and data removal rarely happens. So we're continuously scaling our file system and storage capabilities for our national science needs. Move on from this. So my area is cloud systems. We run the Niren Cloud, which comes from the Wiradjuri word for the edge. Niren is an infrastructure as a service cloud based on OpenStack, which allows us to deliver edge case services which fit alongside and support traditional high-performance computing workloads. So Niren is used by both internally by NCI for our data catalogs delivery, our virtual machine provisioning, a lot of the web-facing services and long-running services that we offer, as well as by our stakeholders for similar capabilities. Our NCI cloud, Niren, was repurposed from our old Ryzen supercomputer. It occupies, 22 racks across 2 data centers with approximately 44,000 cores at the moment. We've got a range of system architectures from Broadwell, Sandy Bridge up to Skylake with 100 gig and 56 gig interconnect. That's backed by 6 petabytes of operational set disk storage. As I mentioned, we support all aspects of NCI service delivery. We support our stakeholders as their delivery platform, and our infrastructure as a service allows our stakeholders to configure a programmable environment of compute, storage, networks, and security rules, which can be scaled up and down to meet their requirements. I ARE is our Australian research environment, which is a web-based interface to our Guardi and Mirren systems. It's based on Open On Demand from Ohio State University. And we've incorporated the best aspects of our virtual laboratories, which we've developed over the last 10 to 15 years, into application-rich, discipline-specific environments with sets and tools and workflows optimized so users can basically get started on HPC really fast without all the barriers to entry. It's a GUI interface, a web-based GUI interface supporting terminal, traditional X11, emerging Jupyter notebooks, and it integrates with Globus for managing large data transfers from a single interface. I'd like to move on to the Data Mover Challenge. High-performance networks are the key to data sharing, both nationally and internationally. We need to look at things like fair and care. NCI does not impose ingress or egress data charges, and we try to support, where possible, friction-free data movement. High-performance computing and combinative science brings data together from a range of sources, from satellites, telescopes, sensors, Internet of Things, ultra-high-definition images, genome sequences, and external data sources from around the world, things like LIGO, LHC. There's an evolving range of large science combinative data processes which are distributed around the world. Our data workflows for satellites, which is something that is also a very high used service, occupying around 5.9 petabytes, is our satellite data services. We perform geo-rectification, cloud removal, light and color adjustment, and then add it to a data cube for longitudinal and transectional retrieval. So, for an example, you can return for a given polygon, return all of the data for 20 years, identifying vegetation types and extent. This is used to things like plot changes in water flow in our river systems, look at bush clearing that has been done without permission by the state governments, and also flows into our natural disaster management, preparation and warning systems. Our cloud capabilities are traditional infrastructure as a service and platform as a service. We tightly integrate with global data and high performance. So let me move on to the Data Mover Challenge. This slide shows just some of the subsea cables connecting our nations, which form our global RNE networks. Australia is well served with multiple 100 gig connections running diversely away from Australia, which give us multiple paths over points of failure in the ring of fire. The International Data Mover Challenge is a component of Supercomputing Asia. It operates every 2 years to identify the best practice for systems, networks, and tools for large data transfer. We aim to bring together experts from industry and academia to test their software and solutions for transferring huge amounts of research data. It operates over production, research, and education networks, and is critical for Australian network capabilities. As the most distant network user in the world, we collaborate with the international research and education community and our data suppliers like the European Space Agency to tune for timely delivery of data products to NCI, so we can then distribute them further at high speed to Australian researchers. The Data Mover Challenge has been operating for a number of years. This was our first Data Mover Challenge topology. This was operating as a layer 2 extended VLAN network over traditional RNE networks. This unfortunately had a number of unexpected side effects, and we rethought the process for the 2023 iteration of the challenge. We're also really glad to be able to add both South America and Saudi Arabia, so the Arab Peninsula, as participants and transfer nodes for this year's DTN. And we're looking forward to potentially adding Antarctica for the next DTN. So this year, this iteration stretched across 5 continents. It modeled 2 data transfer scenarios, 100 gig RNE production networks, and a Starlink for field-based data acquisition system. And the Australian Antarctic Division has recently installed Starlink, and we're negotiating with them to have Starlink at the South Pole for the next Data Mover Challenge. I'd like to thank all of our Data Mover network partners around the world who were instrumental in making this happen. Also, our data transfer node operators, once again, spread around the world. So the challenges to large data transfers over global networks are disk management, access management, protocol adaptability, OS tuning, scheduling processes, and I/O strategies. CPU, I/O, and network latency, lots of small data, or lots of small files, which has metadata operations. Parallelism, and most importantly, keeping the network full. If you are trying to saturate a 100 gig network, you must keep at least 3 seconds of data in the worst case scenario in memory, in buffer for packet acknowledgement, depending on the congestion protocol that you're using. So protocols which make dynamic adjustments based on network conditions perform best. The judging panel was drawn from Singapore, Amsterdam, Japan, Brazil, the UK, and Australia. And I'm honoured to be the chief judge of the Data Mover Challenge. I'd like to briefly go through how each of the teams put a really unique and different approach. I'll just summarise quickly some of the different methods. This is in no particular order. Team Falcon, a university project, University of Reno, Nevada project, was inspired by hands-on experience and trying to understand the data provides insight into the best methods of data transfers. So analysing the data set for lots of small files, lots of large files which are eligible for parallel transfer, and pre-profiling the data set. They also had a very unique and heuristic feedback mechanism which dynamically transferred information between the sender and receiver agents based on live telemetry conducted during the data transfer to perform I/O optimization and network parameter adjustment in real time. Team Cyto, DTN optimization using dynamic network estimation and DTN impedance matching, used a part of the Sienna environment for network innovation, network and test beds. They used a remarkably advanced automation and machine learning model to optimize transfers. The model takes into account homogeneity of DTN deployments, which buffer sizes, host buffer sizes, timely data delivery, so adaptive buffering during transfer, and is able to adapt to non-deterministic network conditions. It's provided as a DTN as a service module loaded on a Jupyter notebook. Team Cyto have participated in the Data Mover Challenges on a number of occasions, and their work is exemplary in the way they keep advancing the field. Team Livewire from Australia is based on a commercial product called MediaFlux. Their entry was big data through the eye of the needle. MediaFlux provides a complete fabric for data management and transfer. It's a metadata-driven automated replication, distribution, and duplication engine for an object-based system. It supports multiple parallel streams, and its main differentiation was the visualization of the data flows for rapid performance indication, and the virtualization storage layer for optimized I/O handling. Team Mushishino from the University of Japan had a high-performance and flexible protocol and looked at the application challenges in high-speed file transfer at 100 gig on global long-fat networks. They have developed a protocol called HPFP, which is designed to perform well in impaired network conditions. Their work was based on trying to provide reliable communications for natural disaster conditions in Japan, where there may be a variety of possible network services available, which can change dynamically. It is a UDP-based design for long-fat networks with packet losses, supports a socket library-based implementation, operates in a number of modes, fair, modest, aggressive, and it performed extremely well over the Starlink. During the week they had for testing, there was torrential rains and typhoon conditions over Japan, and Team Mushishino achieved the highest performance in those really impaired conditions. One of the most notable entrants was Team Just SSH, Ryo Nakamura, a PhD project. His GitHub link is here. It's basically a client-side modification of SCP, which is direct swappable for the standard SCP command. It supports multiple streams. We saw an immediate 10x to 120x performance based over standard SCP. The judges tested this live while we were interviewing him, and for changing just one client-side module, there are no server-side changes needed. It radically improves SCP performance. So if any of you are struggling with transferring data using SCP, I'd suggest looking at MSCP. Team Risync and the Robust HPC Alliance are a commercial entry from Malaysia and China. They use a UDP-based adaptive tuning protocol, which also excels in degraded network conditions. It's excellent at adapting to firewalls, supports compression. It's effective from high-speed, high-throughput data transfer from the field. Their product is used for uploading video recordings and television channels into a central service. So they're able to operate over different impaired network conditions. They also have a complete end-to-end data management platform. So I've run a bit over time. Perhaps we'll leave questions for later. I'd just like to leave you with one final thing. Please hop on down to Sydney next month. It's the Supercomputing Asia will be held on between the 19th and 22nd of February. The website's there, and we'd welcome all of you to come on down to Asia, to Sydney. Thank you very much, everyone.
Thank you, Andrew. I think it was a really very interesting contents. Yes, does anybody question about that? I think Catherine, yes, I think he mentioned already all of the topics when you're wondering about that. If you go to the next month, SCA 2024, and you meet him, and very helpful to you, I think.
Well, John, please pass on my details. I'm happy to do a Zoom call with you anytime.
Is it able to join online, or I have to physically join it in Sydney?
I think we're only running physically in Sydney this year.
Thank you.
Anybody question? Okay, thank you again. They're really great. Bye. Talk to more later. Yes, I want to introduce the next speaker is Woo-Jin Seok. His title is the research is a quantum safe network at Creonet. He is one of the former director of Creonet in Korea. And Dr. Seok, are you ready?
Yes, I'm ready.
Where are you?
Okay, so I'm in the car, so I'm in the way back to my office.
Okay.
Okay. How can I? Dr. Moon?
Yes, you have to click this presentation mode
Okay.
at the bottom of the screen.
Yes, but it's a little bit difficult to manipulate.
Yes, that's fine. That's fine.
That's fine? Okay.
Yeah, that's fine, no problem. And you have to click its presentation mode.
Okay.
Okay. Okay.
Hello, everyone. So I'm gonna talk about the research of the quantum safe network at Creonet. My name is Woo-Jin Seok. I'm working for KIST Korea. It's my pleasure to have time to share my current research to the APAN people here. So as you know, the KIST is one of the research institute among the 25 research institutes in Korea under the name of National Science and Technology. The KIST's main mission is to providing and managing operating of supercomputers and the National Research Network. Today, my talk is about the National Research Network. The name is Creonet. So the many or the ages that is 1987, there was an important proposal to the government that is about the starting of the Creonet. That the proposal was accepted. So the 1 year next, on the 1988, the Creonet, the project is launched and started. So at that time, that is the Korea's first TCP/IP network over the nationwide scales. And a few years later, so 2001, so we can do the connect to the startups. As you know, the startup is the very important the point for all the non-commercial or public networks. So the meaning to the connect to the startup from the ClearNet is very, very important, because almost every research network and the educational network is connected to the Chicago startup. So that was the really important event, and the year was make us to be the high qualified research network. And a few years later, the 2005, the ClearNet joined the global 10 gig backbone project. The name is Gloriad. So together with the United States and Russia and China, we can join the project. So that make us the backbone to be the really high speed. That was one really nice year for our ClearNet. So we celebrate that event at the Seoul. So every the countries come to the Seoul and making us to celebrate for this good event. Nowadays, the ClearNet has the 17 domestic POPs in Korea, and also 1, 2, 3, 4, 5 international POPs, to Seattle and the Chicago to connect to the United States, and Amsterdam to connect to the European country, and Hong Kong and to connect to the China and the Asia country. In the last year, we also connect to the Singapore to connect to the Asian countries too. So this is our really wonderful ICT infrastructure in the area of scientific and non-commercial areas. So many of the persons working in the scientific areas use the ClearNet for their research purpose. So, for example, the telescope data came from the South America and United States, and we transfer that data through the ClearNet to the Korea scientists in the area of the scientific areas. And the famous high energy physics also, we joined this project. So the Amsterdam, the POPs, and the Chicago POP, and that traffic come to the Korea, and we have the special data centers for the high energy physics data. So we store that in the data center, and we disseminate the data in Korea's scientists for their scientific work. So we also providing our dedicated network to Korea VLBI network the peoples. So they require us that they need the faster network, because they can transmit the big data in almost real time transfer. So we have to providing the dedicated network to the Korea VLBI network peoples. So high energy physics and astronomy and the genome bio and the meteorology and even the K-star too. So we're providing the ICT infrastructure in the networking area to the scientific scientific areas. So the Korea's people working in the scientific area has to depend on the ClearNet for their research area nowadays. So, and these days we have have a good chance to developing the ClearNet for the more safer network, because the emergence of a quantum computer has led to a demand for the quantum security, because it can destroy the cryptographic security systems. So that is a good chance for us to get more budget and can make our ClearNet the better ClearNet. So let's move on the topic about the quantum safe network. So the United States peoples working in this area is studying and working about the quantum communications. So Lawrence Berkeley National Lab, Argonne National Lab, and Oak Ridge National Lab, the people in this the national lab is working and studying about the quantum communications. So they making their own the quantum networking testbed in the California and Illinois and inside of Oak Ridge National Lab. So their topics is about the small scale quantum computing interconnections. So they are pursuing the quantum internet. They're also working about the high resolutional time synchronizations between the quantum devices. So, but Korea's the KIST is working about the quantum safe network. So we more focusing about the security rather than communications in these days. So we are working wanted to making the more stronger cryptography. We call that is the PQC research, and we also wanted to making the QKD quantum key distribution networking over the CREONet to providing the quantum key to the site that need more the safer networks. So in the area of PQC, they are focusing about excuse me, the shortest vector problem. That is very important. The problem for the stronger cryptographies. You can see that finding the shortest vector in 2 dimensions is very easy. However, as the dimensions goes higher, it really takes time to finding the shortest vector. Hello.
Okay.
Hello.
No problem.
Oh,
Go ahead.
slides doesn't work.
Really?
Yep, it seems to be a little bit stuck. Okay, oh, it works.
Depends on your side.
Okay, let's keep going. So as the dimensions goes higher, the finding the shortest vector really takes huge times, as you see in this figure. So it's the log scale the figure. So we wanted to we wanted to know how the quantum algorithm takes times, how smaller times the quantum computers is take for this the SVP problem. So that is our the current research. So we the studying and researching about the group algorithm because it takes order log root n scale for the linear searching. So we making the quantum circuit for the groove algorithm, and we learn making the Python code for this the quantum circuit, and we learn this coding in, course to in the IBM the Q quantum computer using the Qiskit the front the server. So we learn this the groove algorithm using the 27 qubit of the IBM quantum computers. We are still working and studying about the result, and we want to still working about the analyzing how the group algorithm takes the time for the analyzing this the SVP problem. This is our the first year research about the PQC the algorithm. So we will keep doing and about this research for this year and the next year too. So finally, we wanted to making our CREONet to be a stronger CREONet against the quantum threat. That means the quantum computers attacks. The second the quantum technology research is about the QKD. So QKD is a quantum key distribution network. The QKD requires the dark fiber optic networks. So it's very expensive the technology. So fortunately, CREONet has our own dark fiber network in Daejeon. So over the dark fiber networks, we building the QKD networks, and we also made studying and implementing the key managing system over the QKD networks. So we providing the 2 user cases for the implementing the QKD examples. So first one is the bioscience areas. So our government has data centers at the Daejeon for storing the Korea people's bioscience data. So our government also has the backup data center at Ochang. So we providing the QK network between the Daejeon and Ochang, and so making these two cities connected using the QK network. So that means the transferring and accessing the data between the two data centers is very, very secure, more than before. So that is the first example. The second example is around about the aerospace data. So our government also has the aerospace data at the KBSI site. That is one of our research institute. They also has the data server at the KARI. It's a Korea Aerospace Research Institute. Between two research institutes, we providing QKD networks using the QKD devices and the QKD key managing systems. So we making this link to be more secure than before. These two cases is our just two pilots based on our QKNet. So we are still working more on to making the complete using the key managing systems and more the software stacks. That's my last slide. I looked over the technical elements of the KREONet, the National Research Network of Korea, and the technical considerations for the quantum technologies were also explored. I hope this talk, my talk, will be helpful for your researches. Thank you.
Okay, thank you, Dr. Seok. The very interesting contents about this quantum safe network. And does anybody questions for this topic? And I hope it's in the near future, and I want to apply this quantum safe network technology to our big data superhighway and the research platform. And
Sure.
thank you, Dr. Seok.
Okay, thank you.
Thank you, bye. And I wanted to introduce his next presentation, and Birachai Tampipat from Thailand and Sujin Yang from Korea, and they share their time and the pronunciation announce their topics about. Okay, using.
Oh, okay. All right. Okay. Okay. Good afternoon. I hope you're not sleepy. Philip, are you sleepy? No? Okay. Well, this is something a bit different that we are looking for the application, try to manage or doing some like early warning or database management or dashboard for decision making. We still in the idea of doing this for FOCO members, which is Susan can explain a little bit later, 15 countries. And it's FOCO is based in Korea, so it is a good opportunity to try to hook up and get support from Christy that can help out on this effort. So it's we try to do this. This is not working. Okay, no, it's not working. The capacity building for the forest, hydrology, and climate change disaster related, but ไม่ได้ผ่านหมดไม่เป็นไรหรอกอ๋อโอเคมาเอาเจอนี่ครับโอเค so I will talk in the part and then the Susan will talk another part ไม่ถึงนะoh maybe you can just move it for me then instead it's too far maybe yeah I know but to move the slide maybe too far from the กดตรงนู้นได้กดไปตรงนู้นดีกว่ามันไม่ถึงมึงไม่ถึงokay this is the content just next slide please just introduction this is like the climate change and the effect that we are having last year. This is the summarize that the NOAA have been doing every month, but this one they do it in the 12 months last year for 2023. What happened? So all over the world. So this is just the example why we are trying to do this system. Next, please. Also, this the data, the precipitation are the different that they collect the data. Where is the anomaly happened? Just to show that. Next, please. The same thing that the temperature hitting higher and higher. This is the temperature. So you can see that 2024 now we almost every month we have hit the highest temperature average of the world. So it's going up and going up, and we don't know what's gonna happen. But we expect that this disaster related to this climate change will be more severe and heavier. I mean, like intensive, more intensive. And then we try to get the system that can help manage this. Next, please. Just for example, why we are doing this is the summary from the US itself that they lost from the disaster $billions every year. So next, please. This is also the amount of the money that lost from each different type of disaster. That's to show that it's a lot increasing every year. So more now it's like 600 billion, I think, some 600 billion that losing every year for the US only, not the global. Okay, next, please. Also, this is about the forest fire, but the data is like from the European Space Agency that they estimate each year. This is the average each year that is the same size of India. I guess larger than India. This is we have a burn area, but if including this year, what happened in Canada, going to be a lot more than this because Canada is burning. I think the number. Oh, next, please. I think that I haven't. This is the number of fire. Number of fire we have less, but the size of the next, please. The size of fire. Not double. This is for Canada only. It's not double. It's triple. I don't know, 10 times more or 11 times more because it burned 20 million hectares. Only one country. So the fire is getting more intense and very difficult to control. So the best way, if we have the system that we're going to propose here, we can attack or try to control fire faster if possible. So the fire is still small. Next, please. This is a regional initiative on the ICT-based forest disaster response for the climate action, which is Susin and I trying to start it. And we have detail inside that the goal of this regional initiative is to create a disaster resilient society through innovative forest data management and techniques that can cope with the climate disaster through the mutual collaboration and cooperation in Asia. But we will start this with the 15 countries first and trying to expand to because we have to start with the member country first. Next, please. And this is the example that the climate change effect that happened. We have more flooding, we have more fire, everything intensify. You can tell that the last one that very surprising me is this I don't know type they call it hurricane that hit Mexico. Is intensity change from the 0 category to 5 to category 5 within 24 hours. So the warning of the impact that this cyclone or typhoon is more difficult, and everything changing fast because of the temperature of the ocean is going up, and we really cannot do anything much. So we have to get the good system. So the effective governance is crucial for the management disaster risk and ensuring effective response and recovery. We're not only looking for this response to the disaster. We also doing the recovery, like Afoco have a plantation, reforestation effort, which I don't know how many million hectare, but Susan will give you more on that. It's I don't know how many million in the Central Asia. So next, please. So so we need to have the inadequate understanding of disaster. Each disaster different, and and the integration system. When you have information, you also need a good system to manage and give you the useful information out of those databases that you have. So we really need this system to manage and give the warning to the people and use it to recovery state as well. So member countries need to access to reliable information and early warning system for the forest and climate change related disaster. And there's a pressing need for genius committed cooperation at all levels to effectively address and resolve forest disaster issue. Forest disaster issue is like, okay, it's a forest fire, landslide, also anything that happened on land. So if even the typhoon happened like from Philippines, but then when it moved to Vietnam and also hit Laos, northern Laos or Thailand, this also means forest related is on land. Okay. Next, please. So we have this primary issue that we identify when we had the training for the 15 countries. So we asked them to look at what could be related, let's say that you need to look at. Then we identify 4 from the participant that they recommended from this 15 country that they come for training, 1 week training with us. So we have this to ensure effective prevention and reduce damage and loss from the forest related disaster. Okay, and then to create the exchange information hub. So this could be like a cloud system. You know, what I'm saying is a cloud system that it doesn't have to be at each individual country, because it's now we have such a technology, so we can use that and easy to manage rather than each member country has their individual server to manage that. Next, please. And then we have to reach the decision maker as well. That's a problem always happen, that the as I said, the scientific data not really reach to the policy maker, and you need to do this. We have to try to find easy way to communicate. So when they make decision, it's better than using the feeling only. So they based on this scientific information as well, which is lacking most of the time, lacking in ASEAN, let's say. I can say in ASEAN, they just political. The politician people, they make decision on their feeling more than based on the scientific. But sometimes you have to understand, they say the reason is that your scientific fact or study or research not coming out on time. It's too slow. They want to make decision now. So we need to improve that. And then to successfully handle and overcome the problem of disaster related to forest climate change, individual country must sincerely promise to be open-minded. It's sometimes you come to the meeting and you promise so many things and nothing really work because of this. So this will strengthen our form of regional and international collaboration as we start at 15 countries and we can move on. Next, please. So Susan, maybe you can do this.
Thank you, Dr. Chai, and good afternoon. My name is Susan. I'm the I'm working for the Secretariat for Asian Forest Cooperation Organization, AFOCO, which is the intergovernmental organization with a member of 15 countries in Asia. Actually, the Secretariat is only support the member countries. Mostly these ideas are come from the demands from the member countries. Whenever we have capacity building workshops and conferences, we have all rounds of surveys and discussions and open discussions. And this is one of the strongest demand from the member countries, because forest disasters are not only within the sector of forestry, now it's the impact of the climate change issues. So these are the major things foresters in Asia realize, and they now know that the information needs to be shared in order to make the decisions much clearer. So based on these situations, we developed this idea. But the thing is that the experts in the forestry is not enough. We realized that mostly the data scientists and information and IT researchers and more cross-sectoral collaborations needs to be here. So that is why I participate in this APAN first time to look for more partners and build up networks for the future collaborations. So under this situational analysis, the first objective of the regional initiative is, of course, the establishment of the information and decision support system. And the next, please. And when we have just a brief surveys with the member countries, what kind of specs and scope this system needs to cover. And most of the member countries should gave us comments that at least the system should be, of course, GIS-based disaster information they need to provide, and also not only land information, but also air quality monitoring needs to be there. And based on the information, they need to enhance their level of decision, the quality of decision, much science-based one. So that's why early warning system should be there to support their national level information system already exists in each country. And emergency response mechanism, if possible, they would like to have that in order to collaborate neighboring countries to support. Sometimes the issues are not only within the domestic issues, sometimes it's transboundary things. So that's why they want to build up this mechanism. So next, please. But the thing is that what I also learned from the last couple of days in other working group meetings and master classes of Dr. Virasai, that each country has already wonderful national level information system. But the thing is that sometimes the information is not so well accessible. So that is why they need some common area to safely share the data information each other, some kind of neutral zone they would like to have. Next, please. So that's why we, next, please. So that's why we would like to propose the national dialogues regularly, so that we can also use this platform of APAN, so that we can invite the member countries to share their challenging issues, and also they can encourage themselves to develop the communication channels to how to make the data safely shared among the member countries. And also for that, capacity building activities are set in this regional initiative. But even though we have these kind of discussions only with the member countries, but it does not mean that we only collaborate with the member countries. It does not have any limit. Any countries beyond Asia also we can collaborate. Anyhow, we would like to support the country's governments to enhance their policy, the disaster governance level, which is the strong demand from the member countries. Next, please. Maybe Chai?
Yeah, so I just give the opportunity to introduce you that Adrian not here or he left. This is we also have the ASEAN Hydroinformatics Center based in Thailand, but currently chaired by Singapore and vice chair by Vietnam. So just want to introduce that this is also there. They're trying to do a data center, and we have these three pillar, knowledge sharing, technology matching, and capacity building that each country can exchange. But so far, in terms of data, it's very difficult because of the government level. This is government level, government agency level that they agree upon to have the side in the ASEAN level to help each other when the disaster related for the hydrology, hydroinformatics can help. Okay, next please. And this is 5 things that we would like to do that we identify. So we keep exchanging, but the problem is still the same. At the beginning, the people participate more, then later it's die down. So to really keep it up, it's quite difficult. And now I can tell the fact that the Singapore is very frustrated that not other member country not really engaging when the time pass. So but they don't know how to motivate and make it the member country to participate more. Next please. So this is the plan, the roadmap that we agree upon since 2020. And now we're in the phase 2, the technology matching and capacity building. So we're doing the training from the expert from Vietnam, from Singapore, because they are chair and coach, our chair and vice chair. So they're trying to find the expert in their country and give like kind of a webinar or online training. So, and then we look forward to the application in the next 5 years. We have 2 more years in this. And we also got for this, we also got funding from Asia Connect, one project called CRADA from this 3 working group: disaster and agriculture, and open and sharing, to get the funding, and hopefully we can extend it when Asia Connect open again. Next, please. So in conclusion, it is time to encourage and accelerate the creation of a new Asia community, not ASEAN, Asia community for research and operation support that is focused on open and sharing data, open science technology, and open science. UNESCO also attend very often now, every time for 2 years now, they come and they would like to do their open science. So from the open and sharing, we extended to open science. But before you do open science, you have to have data and information to do that. By creating a community for practice, assessing, and in the estimate of a culture and policy framework for data sharing. The problem that we identify is the culture also, that the people are so afraid that to share the data. So it kind of a cultural change as well that we have to do. But this thing takes time, long time. For example, in the Australia, we use the Marcus always give the good example that in Australia it took them 20 years to try to do it. But we try to start here in the APAN. And then we have a wide variety of culture, political systems, so socioeconomic status, and then technologies within the focal, and perhaps including ASEAN community, which can support each other. That's my conclusion. Thank you very much. You have any?
Okay. Thank you for Dr. Chai and Dr. Yang. And does anybody question for this contents? do you have the strategy or the plans to how to build the computing environment or the ICT infrastructure as your the aims is achievement?
That's the problem. That's why we have the idea, but we not actually know how to really do it and make it. So that's why we had Susin and Dr. Lee went to Daejeon to meet try to meet you, and then so yeah, your team to try to Christy to do it. So is this you have any recommendation or anything?
Okay.
Yes.
Welcome to APRP.
Okay.
Okay, does anybody question? Okay, I want to introduce the next presenter. Next presenter is Kyu Kim from Kistin, Korea. He mentioned about this wireless communications. And the wireless communications is one of the major applications, the combination with the research platform, because it's the 5G or 6G technologies is more than the powerful than the wired network. So so many the network engineers and the network guys is want to using the 5G or 6G and the totally the wireless communications is capability to adaptation to everywhere. Dr. Kim, are you ready? Dr. Kim? Dr. Kim? When you're ready, I think your mic is just on mute. Please turn on your mic.
Can you see, can you listen my
Yeah.
voice?
Well, and where your the presentation file and your voice is good. And well, whenever you're ready and you start.
Yeah. Hello everyone. I'm Yu Kim, working at KIST. Sorry. And okay. I'm very glad to present my work here today. And my research scope is wireless communication infrastructure for research data transmission. I'll give a presentation about the research, especially for new IoT capability of 5G cellular networks. And I'm not a 5G expert, so I may not be able to elaborate on the technical details. The 5G is so difficult, not only for you, but also for me. So please feel free to listen. Okay. At the REST APIP working group session, I introduced the wireless data transmission project of KIST. This page summarizes what I explained at that time. We've been working on scientific data collection using IoT since 2018, and from 2022, we extend the IoT project to the study of millimeter wave and sub-terahertz based scientific data transmission. The 60 GHz frequency has features with low radio interference and enhanced radio security, and its unlicensed frequency band assigned by each country has bandwidth exceeds 8 GHz, so we can achieve very high throughput with it. And additionally, the 60 GHz frequency band is the frequency used by the WiGig standard of the Wi-Fi Alliance. So you can easily get commercial radio devices of 60 GHz in the device market. And I also said that 60 GHz mid-range radio links between KIST buildings are constructed in 2022 and 2023. I told you our 60 GHz radio link construction process and its results in the last presentation. Now, today, I will show you another potential alternative of wireless communication technology for scientific data transmission. In 2022, 3GPP release 17 is freezed. The release 17 is the extended version of global 5G standard. The 3GPP release 17 contains some performance boosts on the 5G system, and it also contains some expansions of 5G into new devices and applications. I would like to introduce the RedCap, one of the devices and application expansion in the 3GPP release 17. 5G RedCap is also known as NR Lite, is an abbreviation of 5G reduced capacity. It scales down the existing wideband 5G features such as reduced radio bandwidth and reduced antennas, reduced modulation and other stuff to efficiently support lower complexity IoT devices. Note that it is lower complexity, not the lowest complexity. The lowest area is for the LTE-M and NB-IoT. I will describe about this positioning on the next page. Anyway, RedCap scales down wideband 5G NR designs bandwidth from 100 MHz bandwidth to 220 MHz bandwidth. Only 1/5 of the bandwidth is used for RedCap. And the RedCap also reduces the number of antennas required at the device from 4 antennas to 1 or 2 antennas. And this reduced complexity of the device can reduce the cost of device by 50% to 65%, and as well as its smaller form factor. And the RedCap contains enhanced low power modes and enhanced network efficiency, supporting coexistence of half and full duplex devices and reducing signaling overhead, and optimize the coverage using relays and side rings and other many things for IoT devices. Comparing the peak data rate capabilities of 4G and 5G device types shows that at the high end of both technologies, there are device types offering high peak rates for demanding use cases. Between the low and high end, there is a range of 4G devices available, and RedCap will provide corresponding 5G device types for this mid-range segment. Achievable downlink and uplink peak data rate for RedCap devices depend on the complexity and frequency band. It ranges from 50 megabps in the downlink and to 240 megabps for the simplest devices, and from 130 megabps to 145 megabps for the most advanced devices. What you can see here is that RedCap can provide sufficient data rate for real-time transmission of image data and video data with the level of broadband service of LTE. As you know, NB-IoT and LTE-M, which have been used for IoT so far, are insufficient in data rate to transmit image and video data in real time. But the RedCap targets devices that require higher performance than them, so it can easily support the higher bandwidth. This graph is the market readiness of the new 5G technologies in Ericsson report. The readiness, this readiness means that one or more network infrastructure vendor and user device vendors will launch their products in the market. So this graph shows that the new RedCap devices are coming to market in the first half of 2024 this year. It means that we will be able to meet RedCap devices in the market in a few months. This is the last part of my presentation. The RedCap enables a wide range of cost-effective and power-efficient use cases, such as wearables, for example, smartwatches and IoT devices and AR glasses. It is expected to be introduced on low-cost routers, cameras, high-end meters, and fixed wireless access devices before it advances into the wearable and industrial application segments. I think communication technology stable for these new devices can be used for wireless connection of various research equipment. When you consider RedCap for wireless communication of your research equipment, you can consider many requirements as shown in this table, such as data rate, latency, reliability, battery lifetime, and others, and determine whether RedCap can meet your requirements. And I said before, there may be some mistakes in my presentation because I'm not a 5G expert, but I think it would be worthwhile to introduce RedCap today if it can be considered when you need wireless connection of research equipment in your research environment. Thank you for listening to my presentation.
Yeah. So thank you, Dr. Kim. Does anybody question for this wireless communication? Yes, I have one thing. Are you there?
Yeah.
Yes, I have a question. Is what is your next plan? Is 5G technologies apply for the third party application? Do you have any plan?
Not in this time, but
yeah,
I will think about that later.
I just the thinking about is that for the forest fires and the environmental areas, how can the deploy this the wireless communication for sensor or the sensing? Yes, and the everyday environmental problems is a long distance from the city.
Yeah,
It's very not easy to access. At the time, is the wireless communication technology is very important to probe that. Okay, thank you, Dr. Kim again. And our session final the presentation is the Nurul Professor Nurul she came from the UPM in Malaysia, and she announced the aviation infection disease, some related work. And are you there, Professor Fija?
Yes, can you hear me?
Okay, I can hear you well, and share your presentation file, and when you're ready, go start.
Okay, sure.
Okay, just perfect. Go ahead.
Okay. Okay. Good afternoon, everyone. Okay, so my name is Nurul Fiza. Basically, I'm from the University Putra Malaysia. I'm a cell molecular biologist, so I might not very familiar with the technical term in terms of the HPC networking and everything. But I will share some sort of my experience from the end user with the application of the HPC. So here I present the updates, okay, a data-driven in the fights against the poultry infectious diseases. Okay, so this is a topic overview. So I might present a brief overview of the poultry industry in Malaysia and the disease, and what's the current research framework and future direction of my laboratory, and then the facilities and what's the ecosystem that support towards the framework and the future directions, and how actually the data-driven bioinformatics could transform the poultry health monitoring in terms of the HPC application, and a brief on the world of HPC and how extreme HPC is required and the requirement that we need in terms of to fulfill the our future direction for this poultry. Okay. So basically, the livestock is the second highest contributor to the value of gross output for the Malaysian agriculture sector. It's about 18.7 billion, where poultry itself is contribute around 16.8 billion. And Malaysia itself sufficient for the poultry meat and eggs, with where Malaysia consumption is among the highest in the world. So it's about 51 kilogram per capita per year. So this one is from the Department of Statistics, Malaysia in 2022. Okay, so basically the rapid growing of poultry industry, however, not free from many issues and challenges such as high production cost and emerging and re-emerging diseases. So to date, almost all non-major poultry diseases have been reported in Malaysia. So prevention and control of poultry diseases involve complex understanding of the interaction between the agent, host, and environment, and this can usually be achieved by proper biosecurity, vaccination, and flock health management program. So it's difficult, expensive to always maintain a high level of biosecurity, and those poultry vaccine and health management program are powerful tools in disease prevention and control. Okay, so basically here I'm sharing with you the research framework and future direction of our laboratory. So basically, our institute in UPM is focused, or our niche is on the poultry vaccine and therapeutics. So as you can see here, we developed three main programs, which is the vaccination program, novel breeding program, and also the diagnostic program. So basically, this program to make sure that will give impact to the food safety and security, and also to improve the farmers' productivity and also the food sustainability. And beside of that, we also do some education and training and then do some knowledge transfer to the community to address some issues and challenges where some of the farmers, they are lacking of awareness on what kind of infection and then how to prevent against the infectious diseases. So with that, we need help in terms of the collaboration and working from our partner industry also, right? So basically, to achieve our research framework and also the future direction, so we need to have a support in terms of the facilities and the ecosystem. So basically, in our laboratory, we have this main three lab to support the future direction. So basically, this is the ecosystem to improve food security through the poultry vaccination and novel breeding program, and also the disease diagnostic. So as you can see here, we have the vaccine and diagnostic lab where we do the molecular part. We develop the vaccine, we design the vaccine, and then we design also the diagnostic kit. And then we offer the service for disease diagnosis. And then from that also, we also run the experiment. For example, like if we develop the vaccine, then we need to do field trial experimental trial in the lab. So we need the avian research and isolation facilities. So basically we have the ABSL2, animal BSL2, and then currently we are looking forward to upgrade into the ABSL3 to cater the infection like AI, avian influenza. Okay, and then this facility is where we do the vaccine potency assay, vaccine efficacy, and also the improvement of the poultry breeding program. And then, of course, related to this discussion this afternoon, so basically, we also looking forward to have the omic bioinformatics facilities. So this one is very important with the HPC integrated for genomic selection and also the surveillance for disease diagnosis and prevention. Okay, so basically I focus on this laboratory that focus on the what we call the data driven. Okay, we call the omics bioinformatics. So basically this laboratory is focused on the novel breeding program and also the disease diagnosis or disease diagnostic, right? So the objective is to strengthen the disease diagnosis and surveillance system as well as to design the novel breeding program through sequencing and bioinformatics facility. So basically, we are looking forward to upgrade the existing lab into a fully functional bioinformatics facility. So currently, this is the pipeline where the sample that we get, we run the PCR real time, and then we have in the lab, wet lab, we have the short read sequencing like MySeq, and then we also have a medium type of the machine like Oxford Nano to run for the long read sequencing. So these are mainly for the whole genome sequencing, exome sequencing, and then from that data we collect the huge of data. We have the raw data, and then we need to transfer to the bioinformatic pipeline analysis where the HPC is required here. Okay, so this is the some sort that what have been included in the novel breeding pregnancy diagnostic. So we have focus on the rapid diagnostic, imaging, re-imaging infectious disease, viral bacterial evolution monitoring, genomic surveillance, outbreak investigation. So this is why we need the centralized bioinformatics hub. Okay, so how actually bioinformatics could transform poultry health monitoring related to the what we call the HPC application. This is a broad overview of the different what we call data that fall within the scope of bioinformatics. So traditionally, bioinformatics were used to describe the science of storing and analyzing the biomolecular sequence data, but the term is now used much more broadly, encompassing the computational structural biology, chemical biology, and system biology. So both data integration and the modeling of system. So beside that, the field also provides unlimited approaches for researchers to focus on from only genes. So we have the genomic, only transcriptomic, or only protein, or we call the proteomics. So each level of investigation aid in answering a different set of questions. So this science field has the potential to reveal the dynamic changes between infectious agents, genetic material makeup, or protein profile in very short amount of time. So in bioinformatics, high throughput data is analyzed systematically, and results were generated according to the pipeline and software used. So the whole process would eventually lead to the new findings and discovery. So a lot of effort in producing a rapid SDK are currently being implemented. And then before this or the past years, so we have done a lot of research, and then two of them is on the detailed analysis of the gene expression profile of one of the infectious Buza disease virus from we've used the data from 6 different chicken line, and we explore the genome-wide host response against the virus infection. So basically, this is the transcriptomic. So we reported several important genes that are observed to be upregulated and downregulated in all 6 lines during the transcription. So this provide insight of the host pathogen interaction and deserve further investigation as the immunomodulator. So it's becoming a potential candidate protein to act as a molecular marker in diagnosing diagnose chickens in farms. In another study, we also look at the identify novel genes that could elucidate the pathogenicity of the virus following infection and at possible disease resistant gene present in chicken. So we have also do some genomic surveillance in the farm, and then we have identified a new novel variant that have never been reported before the 2021. So we found out that because of the surveillance, so we found out that is the new variant is actually exists in the country. So this is the important part where from the data that we observe, so we will come up with the solution like what kind of commercial vaccine that available that can actually treat that the new variant of this virus. Okay, so this is a very important why we need to do genomic surveillance, and then we have a lot of data to be analyzed. Okay, so HPC is revolutionizing the field of genomics by accelerating the speed of analysis and processing of the large-scale gene sequencing dataset. Hence, we had applied data-driven technology, bioinformatics, which had adopted the proofs of HPC system in pipelines and software to solve the avian disease issues and provide a suitable genomic surveillance protocol. So in our research, sequence genes were pre-processed and applied into an assay of bioinformatic pipeline, such as reference-based mapping, functional annotation, and more. Bioinformatic software often adopted the parallel and the distributed computing system for an efficient, accurate, and time-saving features analysis. Hence, in our avian diseases genomic surveillance protocol, we use the whole genome sequencing, exome sequencing, RNA sequencing, and also some sort of shotgun metagenomic, which is incorporated in the pipeline with HPC environment. So basically, how extreme HPC is required in the bioinformatics analysis. So as I mentioned before, it really depends on the data and choices of the tools used. First of all, see the latest boom in the data produced by this technology. High specification are needed. Assessing any cloud computing services would be better. Other than it depends on what downstream analysis are like. If de novo assembly is included in the analysis plan, then we can expect the even higher specification, for example, Linux-based server for this. It also depends on the parallel amount of data that we wish to analyze and also on the application we choose to use. So means how much data are there in per run, how many replicates are there, also platform chosen for this, whether 454, MySig, as I mentioned before, we have some sort of different machine or equipment to run the sequence to run the sample. Okay, so the different type of the machine, so it will make a different. So it depends on the data also, like what we want to do, whole genome assembly or transcript. So then it would need a multiple core or CPU, better GPU or huge RAM. And then if there are already available reference genome transcriptome, and then we do not need to assemble, so we just do a direct mapping, so the less RAM it can be worked. Okay, so for this current application that we have run in the lab, okay, so we acquire the genome HPC system by phase. So it need to have a modularity and scalability. So this the running for the project. We have the project forecast. For example, like from our previous experience, so we run about 5 RNA sequence project yearly, around 5 times 2 samples. So and then 500 bacterial genome projects yearly. So that's why we need the bioinformatics solution and integrated database. Right, so besides that, we require the installation and commission of biometric software and the job skiller. So this type of the requirements, so we need some help from the like a computer person also. okay, to do some HPC admin and management training. So basically from that data that we have, so we do some sizing and projection, what we call the storage usage over time. So as you can see here, from time to time, so we have increasing the numbers of the RNA-seq and bacterial genome, for example, here. So from this also you can see that we need to upgrade the storage over time. Okay, so this is our target to have a mini genomic labs, okay, which is suitable for the bacterial genome, small plant genome assembly. Because in our lab, we not only cater for the chicken, but we do also some service for another type of research. Because as I mentioned, we do not have what we call a big facilities in our university. So basically, what we have now, as Dr. Asila mentioned, so that is the part that we can actually sharing the facilities together. But in this case, we also look some budget to have some this kind of facilities in our lab to cater the demand of the sequence data analysis from time to time, because we have the request from the company, as I mentioned, not only chicken, but they do also some the nutrition to check the host response. I mean our gene response to the treatment or to the supplement that given to us. Okay, so this our aim target for this one, and then we are looking forward and then work hard for the proposal for this one. At least we have a small mini mini genomic requirement here. So we have this our current spec that we need for CPU and memory, and also the storage around 16 terabyte. So the system that we propose here, so we aim to that we can upgrade later on. Okay, so this is how that we try to consult from the people where they have the core business is HPC. Okay, so to make sure that whatever facility that we have, so at least it can cover for 5 years, and then after that we can upgrade to the much bigger capacity. Okay, and then this is some sort of the pre-installed bioinformatics software so that we need to have, and then because it's the heavily used, so this we have a basic bioinformatics advanced and also the HPC bioinfo. So this is something that we do in progress. Okay, and then looking forward, we are also find several. Look forward for the collaboration to what we call to propose some project like poultry flock health at 4IR. Okay, so which is we need to shape the future of the poultry industry through a holistic approach. So basically, we are what we call seeking collaboration from the company, big company, and to facilitate the farmers and also the small medium enterprise by integrating the biosecurity measure, vaccination, antimicrobial multi-program, landscape program, IoT, and machine learning, and also the high bandwidth display HPC in a single platform for the poultry flock health. So basically, this multi-sectoral collaboration is anticipated to transform and revolutionary the poultry industry by translate the academic knowledge into practice and in line with the National Agro-Food Policy 2.0 to guarantee the nationwide food security. So I think this all some updates from me. So maybe in the later presentation for so we can see what is the either the direction is in line or not, something like that. But I hope that all in place for now. Okay, thank you.
Thank you, the Professor Peter. Does anybody question for these contents? Yeah, I have one question. We can categorize the computing environment, which is CPU intensive system and the memory intensive system and GPU intensive system. According to your last slide, the future the machine plan, the future set of machine plan is is almost focused on the CPU core. And my question is what about the research topics and the contents? What kind of types need for the CPU, GPU, or memory?
Sorry, again, the question, what type of?
Yes, usually we can categorize the CPU intensive and the memory intensive computing and the GPU intensive computing. What kind of type do you need?
Okay, so basically, I think I have highlight some spec here. So, because in the omics part, so we need more CPU in terms of the storage. Okay, because it have a lot of data to be updated. But it's good if we have also the GPU in future, because that one can be fast. Faster the save time for us to, and then get the result more quickly. But of course, as I discussed with the NVIDIA before, that one will give higher cost, which is we cannot afford for that part. So that's why we start using at this moment using the CPU first with the what we call and then we try to find out HPCs for at this moment, and then find out that one is the one that we what we call what we call that we the cost is within our budget, to start with. So maybe if any partner that want to collaborate with us and then want to help us in terms of setup, so that we can work together, and I wish to my proposal before, like to what we call to set up the monitoring program and then the flock health program using the IoT and also the HPC will become true, because once it's set up, so we will try in the small scale and then later expand to the large scale. And at that time, of course, we need integrated with CPU and GPU, but of course, as I mentioned before, I'm the cell molecular, so I'm not used to really know about the current story, something like that, but I try to learn about that one. So at the moment, this is what that we have, that it's not that we have, so we are looking forward for this one.
Okay, thank you. The reason why is why I question about that. The legacy the applications comes from is using Fortran. So the most of Fortran is just the computing, just the computer, and they need computing power. So at the case is sometimes learning is an MPI environment or something like that. At the case, we need the support is the memory intensive and the CPU intensive systems to service. But the AI, the recently researchers is wanted to analysis through the AI model, and at the case is really need for the GPU computation. So why I ask something like that. Okay, thank you again, the Professor.
All right, sure.
Okay.
Thank you.
Now, and we are, all the presentations is complete, and thank you, join our session, and we meet again and talk more at the lobby, and thank you for your attending.